So this one going to be the case for scattering state solution of 1D Dirac Delta potential. I say attracted Dirac Delta potential. If energy greater than V, then particle may exist not in a fixed region but entire space. Then it's said to be a scattering state. So entire state means we say everywhere except at plus minus infinite. With plus minus infinite, particles wave function must be vanished. And the next thing is here as energy greater than V. So in this potential, V has maximum value 0. So energy greater than V, that implies energy greater than 0. So scattering state. Energy less than 0, that implies bound state. So there are two regions. This is region 1, this is region 2. For region 1, our Schrodinger equation always remain same, plus 2me minus v of psi into h square square is equal to 0. As v is equal to 0, so you can remove it. 2me upon h square into psi is equal to 0, and here is greater than 0, so 2me upon h square must greater than 0, so you can write it k square. So our differential equation is now straightforward. d2 psi upon dx square plus k square psi is equal to 0, and it has only one solution. Psi is equal to some constant a e to the power iota kx plus b into e to the power minus iota kx. Similarly, in region 2, v is equal to 0. Differential equation is forward same, but we may write psi as different with extending the constants as c and d. So c into e to the power iota kx plus d into e to the power minus iota kx. So we got psi is equal to a into e to the power iota kx plus b into e to the power minus iota kx, psi 1. Psi 2 is equal to c into e to the power iota kx plus d into e to the power minus iota kx. Now this is our potential V. So it is x is equal to 0. So that means some wave, incident wave, and as at x is equal to 0, there is sudden change in potential. So there is possibility there is a reflected wave and there is a transmitted wave. But apart from x is greater than 0, there is no such potential. That means we consider always that wave coming from left, and if there is sudden change, then some portion of it will reflect back and some portion of it is transmitted back. So here only transmitted wave should there, but in equation we found that this is our incident wave, this is our reflected wave for psi 1, this is our transmitted wave, and there is another reflected wave. So it is not possible because apart from x is equal to 0, there is no sudden potential. So that implies d must vanish. So the wave function remains psi 1 as a into e to the power iota kx plus b into e to the power minus iota kx. Psi 2 is c into e to the power iota kx only, and psi 1 d psi 1 by dx is nothing but iota k into a into e to the power iota kx minus b into e to the power minus iota kx, and similarly d psi 2 upon dx is equal to iota k c into e to the power iota kx. Now we compare the case that at x is equal to 0, the wave function must be continuous. So psi 1 at x is equal to 0 and psi 2 at x is equal to 0. So that implies one thing to us, that a plus b is equal to c. That's one thing. And next we can write here also that we know from the Dirac Delta potential I proved in the previous lecture. Discontinuity in d psi upon dx is arises, and it will be minus 2m alpha upon h cot square psi, and psi of that point where the discontinuity arises actually. So here at x is equal to 0, discontinuity arises. Where at x is equal to 0, there is an abrupt change in potential towards infinity. So at x is equal to 0, there is change in potential. So at x is equal to 0, there is discontinuity in wave function. Then d psi by dx, sorry, d psi by dx. I don't say wave function because d psi by b dx, because d psi by dx is actually related to momentum, and momentum related to energy. So here there is a change in energy, and as it is a scattering state, so we cannot define the particular energy, eigenenergy for every state actually. So in scattering state solution, the energy is not defined particularly. So energy has no eigenvalue. Although you can define some energy for some states, some particular states, or some particular points, but we cannot, like in 1D box, we are defining some eigenenergy. Here we can define some eigenenergy. So here is that, and minus 2m alpha by h square. So psi at x is equal to 0 is a plus b, or psi at x is equal to 0 is c. You can take any solution, but as here we are interested to find some transmission and reflection coefficient, and for transmission coefficient there is something called as j transmission by j incident, which is related to a. So it is better to put psi x0 as a plus b. These are the things, and from this equation, this is our final d psi by dx, this is our initial d psi by dx. So you can find out the discontinuity, and at x is equal to 0, d psi 1 by dx is equal to a minus b into iota k, and d psi 2 by dx at x is equal to 0 is nothing but iota k c. So their difference will be there. So that implies iota k c minus a, iota k c minus a, and plus b is equal to minus 2m alpha upon h cot square to a plus b. That implies c minus a plus b, c minus a plus b is equal to minus 2m alpha by h cot square into a plus b into minus iota by k, into minus iota by k. So let this quantity 2m alpha by h cot square into k as a constant, and denoted this as 2m alpha by h cot square k is equal to some beta. Then our difference, or the condition are straightforward. That is, here we got c minus a plus b. So c minus a plus b is equal to minus 2m is equal to, what we got actually, this is minus beta by h cot square. So this is minus beta, this is minus beta into a plus b, minus beta into a plus b into iota. So this thing we got. That implies c is equal to a minus b into this much. So what we got, a into 1 plus 2 iota beta. I think I missed something. 1 second. Oh, let m alpha by h cot square as beta. So there is 2 iota beta. Let m alpha by h cot square into k as beta. So there is 2 iota beta term actually there. So plus, let's use minus b, because b will be equal to there, and minus b into 1 minus 2 iota beta, and also we get c is equal to a plus b. So with these two conditions, now we able to find out a and b in terms of c, means sorry, I will say b in terms of a. So first of all, I can take the differences it, and this will be 0, and this will be a into 2 iota beta, a into 2 iota beta, and this will be minus b into 1 minus 2 iota beta into minus b. That implies A into 2 iota beta is equal to minus b, sorry, plus b, 2 minus 2 iota beta. That implies b is equal to A iota beta divided by 1 minus iota beta. This will be b, and again putting the value of b in this equation, we can find out c in terms of a. So c in terms of a is nothing but c is equal to 1 by 1 minus iota beta into a. These are the two conditions we get. Now for any plane wave, the quantum mechanical probability density J is defined directly proportional to mod a square. If psi is equal to some constant a into e to the power iota kx plus phi, then we got this condition, that is J is directly proportional to mod a square. You can prove easily by operating J with our probability density operator, psi with our probability density operator, and we will get that J is directly proportional to mod a square. So reflect transmission coefficient is nothing but J transmission by J reflection, J incident, and in the figure we clearly find out that the incident wave is due to psi 1, and here is A into e to the power iota x as incident wave, and this one is a reflected wave. So we got J transmitted as mod c square by mod a square. From this we can find out mod c by mod a, which is nothing but 1 by 1 plus beta square. 1 by 1 plus beta square, 1 by 1 plus beta square is equal to 1 divided by 1 plus, we can put the value of beta now. So beta is our m alpha by h cot square, so we can put right now beta is our m alpha by h cot square, and similarly from transmission coefficient we can get mod of reflection, for mod of reflection mod of b square upon mod of a square, and from this equation actually mod of b by mod of a is nothing but iota beta square by 1 plus beta square, actually beta square by 1 plus beta square. So beta square by 1 plus beta square is nothing but m alpha by h cot square by 1 plus m alpha upon h cot. Now in terms of energy, because we defined 2me by h cot square is equal to k square, and so we can replace here, because in terms of k you can find out energy, and you can put energy as here, because there is a k term, actually I always missing that term, there is a k term actually there. So you can find out the value of k square in denominator, and you can convert these things and in terms of energy.